Okay, so we're looking at the integral of cosine to the third of x dx over the square root of sine of x. And if you look at that kind of suggestion sheet on 7.3 there, I think it says something like if you encounter one that has an odd power, to save one of those powers as part of your du. So we're going to commit ourselves then to making u equal to sine x ultimately. So we're going to take one of those cosines off, and then we're gonna maybe rewrite this as a sine to the negative 1/2 of x dx. And then we're gonna save that cosine x that we picked off. That's gonna become our du ultimately. Because since we have now an even power of cosine left, we know we can trade that in for sines coming from our favorite trig identity that sine squared plus cosine squared is 1. So we know that cosine squared is going to be 1 minus sine squared. So this integral will replace the cosine squared by 1 minus sine squared. We've got that sine to the negative 1/2 of x. And then we've got this cosine x dx that we're going to save to be the du once we get to the place where we can make the u substitution. So we can distribute this sine to the negative 1/2 cosine x dx over the parentheses, and at the same time let's split it into two separate integrals. So the first one is going to be that sine to the negative 1/2 x. And then we've got our cosine x dx that's going to be part of our du. And we'll get minus. And then when we take the sine squared times sine to the negative 1/2, there we go. So we'll add those exponents, making that sine now to the 3/2 x. And we still have our cosine x dx. So now we can make the same u substitution for both integrals. And u is going to be the sine, and therefore du is going to be that cosine x dx. That's the blue part that we have kind of saved off there. So the integral becomes u to the negative 1/2 du and minus u to the 3/2 du.
Yeah.
Okay. And we add 1 to the exponent, multiply by the reciprocal. That makes the 3/2 into 5/2. And then we can go back to our u, which was the sine. Okay, so let's now. So in the, I think the sheet kind of gives you some suggestions. Now, if you don't have, if neither one of them is odd, has an odd power, then this takes us back. You may or may not remember from your AP Prep days. We have to do our power reducing formulas. So we don't have an odd power that we can pick off to use as du. So what we want to do then is get out of this even power altogether. And so there is a formula, it's on your sheet somewhere, where I think it says the cosine squared of x
Equals 1 plus cosine 2x.
Okay, so we're going to do that for, there's two cosine squareds in there. We're going to do that for each of them. That'll start our long journey here. So this is going to be a 1 plus cosine 2x over 2 times another 1 plus cosine 2x over 2 dx, because we have a cosine to the fourth, which is cosine squared squared.
Distribute.
Yeah, so and I would say the denominator is going to be a 1/4. I would pull that outside the integral there. And then you're exactly right. We're going to have to distribute that. So it's going to be the first one squared twice the product plus second one squared. That's going to be 1. And then twice the product is going to make that 2 cosine 2x. Sadly, we're going to get another square. So we have to repeat on that one. Well, let's maybe separate these integrals out. So far, we've got 1/4 times the integral of 1. And then 1/4 times the 2 will be 1/2 times the integral of cosine of 2x. Because those are integrals we can now do. We still got an issue with this next one. The 1/4 the integral of cosine squared 2x. So, and you may remember we go back and do the power reducing formula again. So just this part of it here is going to become 1/4. Yeah, exactly. So when we double the 2x, it's now a 4x.
Always take the integral of each part separately. Okay.
Exactly, yeah. So we'll pull the 2 out and we'll separate these into 2 separate integrals. So that's going to be 1/8 of the integral of 1 plus 1/8 the integral of cosine 4x. Crazy? Okay, so we have 1/4 the integral of 1 is going to be a 1/4 x. Can you do this one in your head? 1/4 sine 2x, good. And here's going to be another 1/8 x. Can you do this one?
Yeah, plus 1/16 sine 1. Or no, 1/32.
Ah, there we go. 1/32. And then I guess we could combine the 1/4 x and the 1/8 x. And that takes us to there. Do you remember doing that in AP Prep or no?
No. Yeah.
No?
Well, I remember the power reducing, I just don't remember doing that.
Yeah. Well, we didn't do the integral part. Okay, so let's look at a different one. Let's do some tangents and secants. So let's do the integral of tangent cubed x, kind of like the one we did earlier, and the square root of secant x. So similar to what we did with sines and cosines, you're trying to, make a determination of which one you're going to call the u. So if the u is going to be tangent, you need to save out a secant squared to be the du. If you choose the u to be secant, you need a secant tangent to be the du. And so it kind of helps you with that choice there. So since we have an odd power of tangent, what will our strategy be? What's that? So let's see. Yeah, we're going to end up making secant the u. And so we need a secant and a tangent to save as the du. So we're going to have to manufacture one here a little bit. So we're going to call this, we're going to pick off one of these tangents. We're going to leave the tangent squared x behind for a minute. This 1 over the square root of secant x. For a moment, I'm going to write that as secant x, secant to the negative 1/2 of x. I'm going to take the tangent x that we picked off there, and I need another secant x to save off as the du. The problem is I didn't have a secant x to pick off.
So you have to make one up at the You have to multiply.
So I have to multiply this secant by 1 over secant, or secant to the negative 1 power, not to be confused with the inverse secant, that's not what we mean. That secant to the negative 1 times that secant to the negative 1/2 is going to make that be secant to the negative 3/2. Follow that? That's kind of clever. So now what do we do with that tangent squared? Good. So we have to get our identity that's got cosines in the denominator. So that's going to be a tangent squared x plus 1 equals secant squared x. So the tangent squared we're going to replace by secant squared x minus 1. And we're saving off this secant x tangent x is going to be our du, because we're committing ourselves to a u substitution of secant. You okay to there? So we distribute everything. We're going to get two separate integrals. So secant squared times secant to the negative 3/2 is going to be good. And we're going to hit it with our secant x tangent x dx as well. And we're going to get minus. And the second integral is going to just be that secant negative 3/2 x. And it's got our secant x tangent x dx is going to be our du. So both integrals have the same u substitution. U is going to be secant. So du, there is our secant x tangent x that we were saving right from the very beginning. So our integral becomes u to the 1/2 du minus u to the negative 3/2 du. So we get 3/2 and then 2/3. We get negative 1/2 and then a negative 2. And then we'll go back to the secant, so it's 2/3 secant to the 3/2 x plus 2 secant to the negative 1/2 x plus c. Kind of crazy? Okay. You want to try one at the board, or?
Sure.
Okay, you can take your sheet with you if you want to get a suggestion on what your strategy is going to be. So let's do the integral of secant to the 4th, tangent to the 3rd.
To the first when we started.
Or another way you can kind of see it, since both identities, since tangent squared is secant squared x minus 1, and secant squared x is tangent squared x plus 1. If you were to replace these by secant squareds minus 1s, the minus 1 is just a constant.
So you can just
That would be obvious or not.
Well, then what about the negative? Because
Yeah.
the flip from, okay, I'm just gonna throw the chalk.
it's like a mic drop with Chuck.
Exactly. The secant to the 6 minus the secant to the 4 versus the.
There's
tangent
more
to the
going
6.
on, yeah, there's more going on. So there was your derivative, so you got it.
I don't know if I did it right though.
Yeah, I think to show they're the same is gonna get kind of ugly, because you're gonna have to go back to, yeah, I don't know, because when, the problem is, you know, if we made that secant squared x minus 1 to the 6th, we're gonna take that out to the 6th power, we don't wanna do that.
No.
Likewise, you know, you're gonna get secant squared minus 1 to the 4th. Yeah, I don't think we want to go there. We'll just trust that it does
I'll
work.
take math's word for it.
Yeah. Let's do one where, kind of like what we did with that sign, when you just have one and it's to an even power. So the integral of tangent to the 4th x dx.
Yeah, that's alright. Yeah, gosh. Can't hold on to it.
See where we're going with it?
No, I didn't.
Oh, and we're gonna do one where you have to go to sines and cosines. You don't have to on this one. Or maybe we do, let me check. Oh, I think we only want to trade one of them in. Not both.
Well, so you get to. Oh, that makes more
One at
sense.
a time, one at a time.
Oh, that makes life a lot easier.
Yeah.
Or you just do it again.
Mm-hmm.
Wait, take two
Yeah.
twice?
Yeah.
And this is just 1/3 tangent. Cube of x minus.
I think it became a plus x though. Right?
Oh yeah, because of the minus.
Minus minus.
Minus.
Okay.
Because it's the minus one here, so you get a minus tangent square.
Okay.
This test is gonna suck.
Yep.
Are we gonna have like a gateway kind of thing for this one as well? Like we did with the other three?
You must know these by.
Okay.
So take your seat. I'm going to walk you through one that comes up somewhat regularly that's really long and lengthy.
Wait a second. I know my face fell off.
You kind of have to see it done, I think, the first time.
Sorry, wasn't trying that.
So this one is going to start with an integration by parts.
We did this in the notes.
So I'm going to split this into secant x times secant squared x dx. Since we know how to integrate secant squared more easily, we're going to say that u is going to be secant x, and dv will be secant squared x. Remember integration by parts? So du is going to
Oh,
be
okay, yeah, yep. Yeah, took me a sec. Okay, so B is tangent.
and v is going to be tangent. Okay, so remember we're taking uv minus the integral of v du. So uv is going to be secant x tangent x minus the integral of v du, which is going to be tangent squared x secant x dx.
Well, and then we have to do it again, don't we?
Well, not yet. First, we want to replace that tangent squared x with the secant squared x minus 1. So secant x tangent x minus, it's going to be a secant squared x minus 1.
So Z cubed x minus
X, yeah. Secant x tangent x. So that's going to be a minus, here we're right back to our starting integral, the secant cubed, and then we're going to get plus an integral of secant x. So we're going to take this and add it to that. So we have 2 of those integrals of secant cubed x. And that's going to be secant x tangent x. And then this is a really tough integral to remember.
The absolute value, or the initial value of the absolute value of secant x tangent.
So we'll divide by the 2. Then don't forget the plus c. Kind of crazy?
Yeah, one of those was either on homework or something, because I got halfway through and I forgot how to do it. And then I remembered it, and I regretted remembering it.
Okay, sometimes you do have to convert to sines and cosines when you just get stuck. So you guys want to try this one? So we're gonna, this one you're gonna end up having to convert to sines and cosines, and then it's like what we were doing earlier when you're using, how do you do the integral of different powers of sines and cosines. So if we have secant x over tangent squared x, I don't think that one will work, trying to leave them as secants and tangents. Want to give it a shot or no? No?
In my head.
Should we do them together? So secant x we know is
Cosine.
1 over cosine. Tangent squared is going to be
Sine squared over cosine squared.
okay.
And then
You're going to multiply by the
cosine
reciprocal. So you know what that's going to look like?
1 over sine, no,
Over
cosine
cosine
over
over
sine squared.
Okay. Okay, you want to squint at that a moment and
You can use this secant tangent.
You can just do use them.
I don't think it's a secant
That's
tangent.
cosecant.
You do a cosecant cotangent, or,
Just do use of
and what would you call u?
Oh, okay, that's probably easier.
Sine.
Might be about the same. So, yeah, so we could say U is just sine X.
Angle keeps the negative too.
There you go. Oh, here we go. So you get that same way you were going, Alec. That's what you were
So,
suggesting.
yeah, that'd be so
It's
secant
just
times
a tangent.
tangent, which
And that happens to be a really nice integral.
negative.
Yeah. So, two ways to skin that cat, huh? Okay, so one more thing to show you, and that's when you have different angles. So when you have trig functions, but they're not the same angle. And these two are formulas we did way back in your AP prep days, but may not have stuck. So integrals with different angles. Again, it's all on that one sheet that you have. So if we do the integral of sine 5x cosine 4x,
I remember these as well.
remember these?
Yeah.
So see if you can find it on that sheet somewhere. And
Bottom, yeah.
It's the middle.
so you have a sine cosine.
Mhm.
So what's that going to look like?
1/2.
1/2.
So
1/2 sine of x
1/2 sine of x
plus
plus
sine of minus.
Okay. That's pretty routine after that, I think.
mhm.
That was great. I didn't think there was any way we'd get through all that. Once again, just narrow the numbers. Make it anything is possible.
Through.
You can go ahead and, if you want, have some time to work on that homework. I don't think any of us have finished them.